In every era, there is a need, a spark, an instinct that brings us together to imagine and to innovate. This hasn't changed. What's possible has. We create technology that makes our world better. Ideas that move us, empower, and connect us. But great ideas cannot thrive alone. They need to be shared, challenged, refined. Through our insight and collective curiosity, we advance and grow. New solutions, new directions, new answers. We do that here, together. This is the age of connected intelligence. Welcome to the IQ era.
Hi, everybody. Welcome to the panel this morning, Data, Compute, Energy, the Power Equation of the AI Era. My name is Jessica Payne. I'm a managing director at the Raine Group, and I'm really excited to be here this morning, joined by three incredible panelists. So to kick it off, before we get into the topic, we'll each go through and introduce ourselves. So Chris, why don't you kick it off, please?
Sure. I'm Chris Bergey. I'm with ARM, Executive Vice President of the Edge AI Business Unit.
Yeah, my name is Hieu, and I'm from Viettel. So we are the ISP #1 in Vietnam and another 10 countries.
Hi, I'm Ishwar Parulkar. I'm the CTO for the Telecommunications Vertical at AWS.
Great. Excited to chat with you all. And as I mentioned, I'm Jessica. I work at the Raine Group. We're a merchant bank. We specialize in technology, media, telecom companies. I lead our frontier tech vertical, which is part of our broader communications infrastructure and frontier tech practice, where we advise companies on capital raises, M&A, and other strategic opportunities. So to kick it off today, this panel, it's focused on the balance between data, compute, and energy, all things required to sustain AI's growth. And every breakthrough in AI really sits on top of an enormous physical foundation of data centers, chips, cooling systems, and all of the assets that telcos already operate. So as we think about this and we look ahead to the next 1 to 2 years, what aspects of this data, compute, energy equation do you see as the single most critical bottleneck? And I'll start with you, Chris, and we'll go down the line.
Which is the most? I think they're all challenged. I think we're at the stage right now where, the workloads are clearly changing significantly, and we're kind of in that space where, I think the old saying was whatever amount of memory you give software, they're going to utilize it. And I think we're in that age where any amount of AI that we can provide enables new applications. So I think there's just pressure on everything. There's pressure on power clearly in the data centers. How much can you push to the edge? A lot of these new use cases have incredible amount of latency requirements, and so can you really, where is the best place for that to happen? And then, how does privacy evolve and all those kinds of things as well. So I just think it's everywhere right now, and it's probably going to be that way for the next 5+ years. That'll just be, whatever amount of compute that's possible, both at the cloud and the edge, will just be consumed.
Absolutely. And Hieu, do you want to chime in?
Yeah, so among three things about the compute, energy, and data. So if you, I remember that there are paper of OpenAI in 2020 is about compute data and the parameter of the output model. So if from my perspective, so the critical thing here is about the effective between the compute and the energy. You remember that DeepSeek, this is the first time the model is very cheaper comparing with another big tech. So and this year and from the end of last year, so you can see that the pricing of every component in the server is increasing high. So the key thing here is, I think, we need to find a way to produce a service and the production that have the effect between the performance, the pricing, and the compute. The data, I think, 3 or 4 years ago, there are some papers, they said that nearly 90% of public data is already consumed by the public provider, AI provider. And the key thing here is the sensitive data, that how we can organize and use this effectively inside the private model, AI model. Yeah.
Thank you.
Yeah.
And Ishwar, what about from AWS?
Yeah, so I'm going to give you the hyperscaler perspective, AWS perspective. Energy compute are definitely a challenge, but I think given our scale and footprint, we have a plan to manage that. Right now, the supply is not enough to meet demand in terms of compute, but we're investing $200 billion. We just announced it's a crazy number if you think about it. In the history of tech, I don't believe we've had investments of this scale, but there's a plan for that. Power-wise, also, obviously, it's a challenge. But given the footprint and our investments in solar, nuclear energy, we believe that's something that can be managed over time. From a telco industry perspective, I think the bigger challenge in adoption of AI is data, really data. We've been working with operators across the world on agentic AI use cases. We have tools now to build agents and agentic systems. The largest amount of time is consumed in just data engineering. Telcos lack data skills and expertise and talent in that space, as well as that's an extremely time-consuming effort right now. So if you talk about adoption of AI really in the telco industry, I see managing data, understanding data, and re-architecting that part of the stack that agentic AI can take advantage of is a big challenge.
Got it. And that kind of leads to my next question. So the three of you are in different industries, and Chris, you're in the chip design, Ishwar in the cloud hyperscaler, and Hieu in the telco space. There's a lot of opportunities across these three sectors for collaboration. And in which ways do you see there being the biggest opportunity for collaboration to help across the energy side? How can you help alter the energy footprint at the AI scale?
I mean, I can take that one first. I mean, I think that, obviously, silicon for the AI era has, consumed both the silicon from a computing point of view as well as from a memory point of view, has put tremendous pressure on bandwidths and capabilities and capacity right now. But I think that basically you start seeing a bunch of things that are custom built for these kinds of use cases, and this is why ARM has grown so much in this space. We were largely known as a handset silicon provider or endpoints, but our business now in the cloud around AI has exploded, and quite frankly, AWS was a leader in this, and so AWS builds custom silicon around their AI workloads, around their compute workloads based on ARM's architecture and the ability to tightly couple those systems with AI acceleration, AI use cases, and all the things that they can achieve at cloud scale. So I think it does require a lot of custom compute. Custom compute is happening big time in the data center. It's happened a little bit in networking around some of the bigger RAN players, et cetera. But I think that's going to be key to really just how much compute can you get per watt is really a key metric.
Yeah, so from telco perspective, so I think that the trend here and the way we will go here is a distributed AI edge. Yeah, so telco, we have the distributed base stations that very near the end user. And like 3 years ago, this event, they state that there is a trend in telco that are calling the autonomous network. That there are use cases in the RAN network, radio network. So we have the base station, and we can do some use case using AI, vertical AI, and energy optimization. So like this morning, there are a lot of people, a lot of users in this network, so we can increasing the power, but in the night, so no more workload, so we can reduce. So we can distribute the AI workload, like we can use some small device that can near the user, and then apply some AI use case near to the end user, and then using the power that we reduce from the RAN network to this AI edge device. That could be reduce the risk in the centralized, like because right now more than 80% of AI demand is inferencing. So we upload the demand and the workload to the edge, and then to reduce the risk of the centralized data center that running the AI training workload. Mm-hmm. So that is the way we are doing right now. Yeah.
Got it.
Yeah. I think all parts of the ecosystem need to do their part in making this, bringing energy efficiency to this whole space. Silicon is a big part, as you were saying, and we have custom silicon. We decided to invest in our own silicon to really optimize it for specific workloads, given our scale and footprint across the world. And we intentionally chose ARM as the core for that because it's one of the most power efficient architectures. And this was before AI. And obviously with AI, we are doubling down on making sure we use silicon that is extremely power efficient. But then building data centers in a power efficient way. I mentioned investment in solar energy, nuclear energy, using those alternative sources of energy is one thing. But I think one fundamental thing that needs to be considered by the industry is leveraging the cloud for the more compute intensive workloads. Cloud is it's a large-scale, multi-tenanted infrastructure. So you get the benefits from sharing the infrastructure with very, very high utilization. Our utilization is very high. I hear talk about a lot of other, on-prem data centers. Those are going to be inefficient, right? You're not going to be able to get the utilization to 80, 90% just because they are smaller, they can't be shared across as many customers. So making sure we use the right infrastructure for the right use case and deployment scenarios is super important to be efficient here. Yeah.
Great. And so as we think about the telcos specifically, obviously they provide connectivity, but they have other aspects of their business model which are unique and differentiated, like their physical real estate, their distributed network nodes, and their direct customer relationships. So how do you think telcos can be leveraging these unique assets to actually give them an edge as they think about the evolving AI landscape?
Well, I mean, I think that Ishwar had touched on the density question about, you got to get to some level of scale to really get sharing of equipment, and because you also have issues where the AI workloads are changing so much. Even when we say training versus inference, I mean, what you actually need to go do those things literally is changing. Feels like daily. It's at least quarterly. And so a lot of the hardware optimizations you do are a trade-off of flexibility. And so that's something that you have to think about relative to how flexible your workloads need to be. But I think the biggest thing that I would say is, and I use this analogy when 5G was emerging, the telcos talked about how important 5G was going to be to autonomous vehicles. But you didn't actually have autonomous vehicle companies talking about how important 5G was to their future. And I think the issue there was quite simply, it was a latency problem, or at least a guaranteed latency problem. And I think we're going to have a lot of the same things happening with AI, where it needs to work every time, and the latency needs to be, for a lot of these workloads, super, super low. If it's a robot, if it's something that's an actuator you're firing or something like that, you just, P99 isn't even good enough, right? And so, just literally today, the way some of these AI workloads work is that when you make an AI request, they kick it off locally on the phone with the local model and also send it to the cloud. They hope they get the cloud model because they know it's higher resolution, but the reality is there's some expectation that you're going to give them the answer in so much of time, so they have to kick that off locally. So how do we manage networks that literally have the shortest guaranteed latency? That is going to be key to at least latency sensitive workloads. And again, each workload will have its own relative to how do you distribute it and what's so latency, what can handle a couple seconds, what needs to be, way sub-millisecond type workloads.
Yeah. So as a telco, we have the distributed network net edge, and as I told that we want to distribute the AI workload inference to the near end user. But the difficult here is that the telco standard is very different with like the cloud provider standard. So if we want to build a hyperscaler data center and we want to providing the AI service, AI as a service like the training or something else with the biggest and the newest technology, so it is very difficult for us to, like the telco. We could not use the same data center for bringing the GPU and then providing the service. The standard for AI and standard for telco is very different. Like for AI, you need at least liquid cooling. Telco, we need just a chilly cooler and the air cooling is enough for the telco. So we need to find a way to cooperate with like the big tech cloud provider or AI provider, because we have the advantage like the near end user, we can bring in some cheaper device, AI cheaper device, and then increasing the latency and the user efficiency. But we are very difficult to collaborate with the cloud provider to providing the AI training and centralized workload. So that's the disadvantage of the telco. We are now fighting away. Yeah. Right.
There's a lot of talk about telcos or operators wanting to use their data centers for AI infrastructure and offering those services. But we don't really believe that is the asset that really brings them the most value. For some of the reasons I mentioned earlier, it's not as efficient. You can't get maximum utilization out of it, so it's inefficient from an energy perspective. You also need the full stack. It's not just about servers on-prem. You need services and a stack on top to really make it useful. So I don't think that's the main asset. There are two main assets I think telcos bring to the equation. One is the customers. I think the touch point they have. Everybody has a phone. And all enterprises need connectivity, right? So it's a very massive footprint and touch point from a customer perspective, and a lot of agentic AI will be consumed by these folks, right? I mean, if you see it, the applications are all for these enterprises and consumers on a day-to-day basis. So I think, to me, that's a valuable asset. As part of the telecommunications vertical at AWS, I work with operators across the globe, and I see this as one of the strongest assets. The second one is around connectivity. How does connectivity and the network fabric change with AI applications, and what can telcos do there? The traffic patterns are changing significantly with AI applications. Yeah. It's more bidirectional. The last generation was all video, which is more downloads, very little uploads. It's bidirectional, it's bursty. There's going to be agents distributed across, so they would need communication across. So I think that's another asset that the telcos have, connectivity, which they've always had, but they need to rethink that in the light of the AI era. We've been working with operators, so for example, with AT&T, we created last mile connectivity that integrates with the backbone directly into AWS services. This is something we announced at Mobile World Congress. So it's a programmable, flexible fabric connecting telco last mile across the internet to the cloud efficiently for AI applications. So this is just one example, but I think that's where telcos really add value to the overall AI ecosystem.
Yeah, on the edge.
Thank you. So, Chris, one question for you, just given your focus on edge AI, as you think about how AI is sort of expanding from the cloud to the edge, how do you think that impacts the energy equation? How does that help or hurt the energy requirements needed to power AI as it moves closer to the edge?
Well, I mean, so edge is a term that it's funny. Every company defines edge at the edge of where they participate in the market. So it's kind of, the edge can be a phone. It could be, a cell tower, and so I mean, we just need to be careful about what we say about edge. But I can tell you that, generally there is the two kind of things that are happening there. One, most AI companies that run some of the largest AI data centers in the world I can tell you are my most passionate customers about wanting to push it out of their data center as much as they can. And the reason is because there's other workloads, there's other things that can consume that compute capabilities and potentially is higher value, right? So it's just simply a value equation kind of a thing. So as much as we can push, as long as it makes sense, and obviously, there's a lot of other benefits of power. You're moving things into wherever you're not paying for the power, the user's paying for the power. You've got the latency, the privacy, all the things I mentioned before. So I think that's the thing that is in favor of it. I think where the challenge is that AI is very compute centric, it's very compute heavy, it's very memory bandwidth heavy, all these things. So it does cause, cost, power, those kinds of things, even in any kind of an endpoint. And so, we'll do everything we can to make endpoints and other devices as efficient as possible, but it's not one of those things that's just easily, we just need a software orchestration layer. You need real computing capabilities wherever you're putting that at your edge.
Yeah, totally makes sense. And I guess relatedly, Ishwar, as we think about the different technologies and technology breakthroughs that have happened as AI expands from the data center to the edge and through the telco networks, what are some interesting technology breakthroughs that you've seen that specifically help address this three-part problem between data, compute, and energy?
I think just new data center architectures for AI is one area. I mean, we are just starting to scratch the surface. The fabric, the whole data center fabric was based on basic compute applications. Now with AI, looking at training and inference as specific tasks, which are going to be majority of the tasks. I mean, you see the shift in silicon already, right? GPUs. Why are GPUs the thing compared to general purpose processors? Is because just the nature of what the computation that needs to be done has changed dramatically. And if this is going to be 80-90% of the type of compute workloads we need to shift the architectures in that direction. And the same goes for data center, right? Data centers are still behind silicon. There is interconnect between clusters and servers that's coming up, which is optimized for doing training across large servers. We're looking at ways of connecting data centers so that you can distribute training workloads. So I think that's still a very open space. We already talk about power. Anything we can do to optimize energy across the stack is going to be extremely important, and we're looking at that as well.
Great. And then Hieu, you have a unique vantage point being at Viettel, being in an emerging economy there. What are some insights and opportunities you see related to this AI power equation that are unique or specific to the region like Vietnam?
Yeah, so in Vietnam, we are the developing country, and like in Singapore, you know that 3 years ago, they run out of energy. And there are some big tech like Amazon, they move to the region near Singapore, is in Myanmar, the Batam, Myanmar. And there are some big tech like Google or Amazon come to Vietnam to discuss with the government about whether they can build a hyperscale data center with the submarine cable to Singapore, Japan, Hong Kong. And to distribute it to the AI workload and to reduce the pressure for the energy in Singapore and Myanmar. Yeah, so I think this is an opportunity for the telco because we can providing the infrastructure, the floor, and then the submarine cable. So this is the advantage point of the telco. Mm-hmm. So the second thing here is for AI. So we see that the fact here that in Vietnam right now, last year we deploy more than 20,000 5G base stations. That's mostly following the Open RAN technology from GSMA. This year, another 20,000. Wow. And next year, we do not know what we need to do. Nothing to do, because right now the coverage of the spectrum is near more than 98% in our country. So what to do next? So we think that with 5G, last year is the first time that we can keeping our revenue is increasing. Yeah, so you know that for telco, keeping the revenue is like this is successful, and normally they will go down. But this last year is the first time with 5G, and a little bit AI, we have the increasing revenue. So that's why this year we continuously improve and deploy more than 5G, and then what we will do next, we will apply AI for the OPEX, for reducing the OPEX, like energy optimization, DC optimization, and coverage, the telco spectrum coverage optimization. There are some use case in this MWC event, like the, how we can archive the autonomous network level more than level 3. And in the floor here, in the hyperscaler data center here, so how we can reduce the energy of some area to balancing the energy of the floor. Yeah, so we reducing the cost, and then we keep increasing the revenue, so that how we can survive and increasing the margin for the telco layers. Yeah, so 5G and then 6G, and applying AI to reducing the OPEX and workforce. So that's what we want to do right now.
Great. Yeah, so you're talking about, oh, sorry, do you have something?
No, I was just say I really liked what Hieu said about how unique these data center requirements are, and it kind of builds on Ishwar. And I don't know if people, you know, many of you I'm sure are super educated on this, but like, you know, literally we went from what, 20 kilowatt racks or something like that to now 400 kilowatt racks. I mean, if you think about a 400 kilowatt rack and what that takes to support in your data center, I mean, it is insane. And so, you know, I think this idea of the telco data center versus the, I mean, it is very unique. Now, again, it doesn't mean all the edge servers and stuff like that will be quite like that, but I do think this idea of specialization is definitely something that people should try to absorb, because it is on a scale that you know, it's not been seen before, and of course we're still pushing the limits, and I don't think it's going to stop anytime soon.
Yeah. So we have what we call the edge continuum. So we built racks of servers, which are AWS infrastructure, the same infrastructure and racks that are in the region, but that can be deployed in other data centers, like telco data centers, right? So we already have a product like that. What we are realizing, to your point, is with AI, it's a different scale, and the power is just not there. We're talking about sets of racks reaching into megawatts. Like one rack is, you know, 100 kilowatts, but the power is just not there.
Yeah.
Insane.
So as we think about everything that AI infrastructure requires from an investment standpoint, Hieu, you were talking about the investment being made in the Vietnamese market. We're all talking about the investments being made in data centers. How do you think about the investment, you know, framework when you are going to be making a big investment into something new? What are some of the leading indicators or some of the patterns that you're seeing in the market or you're seeing from consumers that gives you conviction when you're thinking about making a big investment into your technology or into your network? Whoever wants to take that first.
Yeah, I referred to this earlier. I mean, in the last results, we announced investment of $200 billion for infrastructure for this year, right? Now it's global scale. And the question is out there, I get this all the time. Do you really think, I mean, to recoup $200 billion, what do you need, right? I mean, how much business do you need to recoup that kind of investment? And if you combine this across people investing, it's in the trillions, right? But one thing is it's a long-term play. That's super important. If you don't build it now, it's going to take a while. And secondly, we do see right now we are very, very constrained in terms of supply. The demand is there. There's a tremendous demand, and we can't meet supply given the scale that we have today. So these are signals we see today from customers wanting it, and you know, the way a large cloud works is we have highly optimized algorithms to place workloads as customers want to use them. You give them capacity, you take capacity away when they're done, give it to somebody else. So there's a very sophisticated algorithm and system around that. And we're just finding it very difficult to serve customers at this point. So there is tremendous demand. And if you see the curve of adoption, it's moving from training to inference.
Yeah.
The first wave of frontier models is done. I mean, they will obviously continue to evolve. There'll be new models, new companies, and so forth. But that was what was consuming most of compute. And as we see adoption of agentic AI, we are seeing inference and number of tokens go up. We are hearing tokens in the order of tens of billions from large customers a day, 10 billion tokens a day. I'm just giving you a rough order number. These are the leading large companies who have adopted AI within their company across their workforce. Now just think about that. That's a very large number. You multiply that across customers, and this is the early part of the adoption curve, right? So it's going to just grow more. So we believe inference is where it's going to shift, and over time, there's enough signals to see that part of the economy grow tremendously. So.
I think for me, it's about just the amount of computing capability. I mean, just to add on to your token comment, we're just getting started with some of the agentic use cases. The agentic use cases just take it to the next level relative to token consumption. Just to give you an idea of some of the early agentic OS-like things. Now, again, that word is getting used very broadly, but there's some future kind of agentic OSs that are being prototyped right now. They literally would probably cost somewhere in the order of hundreds of dollars, if not $1,000 a year to generate that amount of tokens in the cloud per user, per cell phone. So if you just think about like what we're trying to create here and what the opportunity is for, from a computing point of view, it's just we cannot add enough computing, and it has to be super flexible computing, because every time people are trying to optimize, you tend to make the wrong decisions, especially with things like hardware or silicon. You're designing out 2-3 years, then you want it deployed in a data center for at least 3 or 4 years to really get the TCO. I mean, we are just moving so fast, and the workloads are changing so much.
Well, Chris, Ishwar, Hieu, thank you so much for the conversation today. I think we're unfortunately out of time, but we'll continue the conversation with everyone else after the panel. Thank you so much.
Yeah. Thank you.
Thank you.
Thanks.